Want to see what the Masuter Pro is really capable of? Well, keep watching. Hey everyone, and welcome to another episode of James Dean Designs. If you're new to the channel, make sure you hit that subscribe button in the corner to get all the latest tips, tricks, tutorials and reviews. Now in today's episode we are reviewing the FoxAlien Masuter Pro. I did a live unboxing and build of this earlier in the year. Link is up in the corner. And for those that don't know, this is the upgraded big brother of the baby version Masuter. Now we're going to cover some of the upgrades that FoxAlien have made to this shortly in the specifications section, but I'm going to start off by actually saying up front I am really impressed with what this machine can do, and keep watching to find out exactly why. But first, let's dive in and take a look at the specs of the machine. So we'll begin with the work area. It's listed as 400 by 400, which is about 15 3/4 inches, but actually it's more like 410 by 410, so closer to 16 inches. Now the reason that's important, it means when cutting things out, you can cut up to 400 millimeters in diameter or 400 millimeters square. So it doesn't sound like much, but in terms of what you can cut out, it makes a difference in terms of getting that rounded value. Now the height of the Z-axis is 60 millimeters, or what's that, 2.4 inches. Now once you take out Z safety height, that realistically means you can cut around 50 millimeters deep, maybe 55 millimeters deep at a maximum. Now the footprint of the machine, now the actual area is 700 by 710, so that's about 27.5 by 28 inches. I'm trying to do both to cover imperial and metric, so hopefully I'm getting all the measurements right. But yeah, so 700 by 710 in terms of the base size you would need. If you are building an enclosure for it, obviously you would need a bit of an allowance around the side. The height of it is 32 centimeters, that's about 12.3 inches, so that is the maximum height you would need for something to sit above this. Now in terms of the frame itself, this has had some upgrades from its baby version, the Masuter, ultimately to make it better, to make it stronger. The frame itself is all metal. We have aluminium extrusion, which is nicely sealed as well, which stops the bits going into it, but ultimately it is 40-20 on the y-axis and 40-60 on the x-axis. Now the reason that they've gone so bulky with this is to allow the z-axis to take more weight. Then it minimises the amount of flex in it, and all being well there should be none at all. Now the Z assembly again is completely metal, so it is nice and solid, but this has also been upgraded with linear rails too for the Z assembly, so it means that spindle or that router is going to move very smoothly. It's going to have minimal play in it and just ultimately get you better results when you are machining things. Now the spindle itself, by default you're going to get the 60-watt spindle with it. Now this is quite small for the shall we say the capabilities of the frame, but it is enough to get you going. But ultimately what FoxAlien are aiming for is for you to choose your own upgrade to this. Clearly like to be a Makita router. Now it can take a 52mm spindle, which is a 300-watt spindle, and the control board is set up for this to be done much quicker. I'll move on to this in a minute, but it can also take a 65mm diameter router, as I say, such as the Makita. In their instructions on the website, they also mention upgrading to spindles. I'd be cautious of that. The average weight of a 1.5 kilowatt air-cooled spindle is around 5 kilograms. That's more than double the weight of a Makita router. That may be a bit too heavy for a machine like this because it has NEMA 17 stepper motors driving all of the axis. These 1.3 amp and about 1.5 on the torque. So my initial concern would be that a 5 kilowatt spindle may be a little bit too heavy, but ultimately if you want to try it and see how you get on, you certainly can. Now as I just mentioned, these are NEMA 17 stepper motors driving all the different axes. You are going to ask, can they be upgraded to NEMA 23s? My honest answer is probably not. These draw about 1.3, whereas NEMA 23 is normally more in the 2 amp range. Might be a bit too much for the control board. But the NEMA 17 stepper motors are more than capable of driving this and also driving a router as well. So actually, you probably shouldn't need to upgrade them. Now, the frame, the wiring itself is all tucked away nicely in drag chains. These are nice slim drag chains as well. They're not too bulky, again, minimizing the foot space of the machine itself. Every every axis is fitted with dual limit switches on the front and the back, and then obviously the top and bottom on the x-axis as well. They are fixed plates in them, so you haven't got much play. The bed itself is an MDF board split into two. It has got all these inserts as well for your clamps and things, making it easy just to pin your material down when you are working. Now it does have a little bit of flex in it. It probably would have benefited from a central support underneath this, and if FoxAlien are watching for improvement, that would be the one thing. As I say, just take out a little bit of flex in that MDF board. Not a huge amount, but as I say, we do look for these small improvements if you ever do a V2 of this. Now all the axes as well, other than the Z axis, run on belts, so you've got your tensioners for these. All runs nice and smooth, as I say, nice and easy, and this is straight out of the box, no calibration to it yet. Now the control box at the front, let's talk about this in a bit more detail. It's enclosed in a metal casing, obviously for protection, stops you knocking and damaging everything. Some of the buttons and functions we've got on it, obviously we've got the on-off switch, emergency power stop, and we also have the homing button as well, so you can home your machine as soon as you turn it on. In terms of some of the ports available on it, we've got a port for an offline controller, we have a port for a laser as well. The switch inside of the casing is to switch between the 60-watt spindle or the laser. So next to, you got two spindle ports, spindle 1, spindle 2. Spindle 2 is to take the 300-watt upgrade that is available for this. Then you also have a port on the side to take 24 to 48 volt input, again for the 300-watt spindle available. Now there is also a little switch on the side for the light. The light is situated right here at the side of the spindle. Little upgrade, but actually it makes life so much easier because you can really see what you're machining out and see the type of detail you're getting in between all that sawdust and everything. So yeah, it's actually a nice little feature that I'm glad they have included. Now one upgrade that I haven't mentioned yet is the eccentric nuts. So if you're not familiar with this, eccentric nuts are a way of changing the tension on the wheels that hold the axis to the extrusion. Now the reason this is such a big upgrade for me personally is actually it's a very simple device. To adjust the tension on the bolts, you put your spanner in and just turn it one way or another to release or to tighten the tension on the wheels. So it makes adjusting this and getting the flow of the machine much easier than older systems like wheel clamps and things like that. So as I say, small upgrade, but for the user it actually makes a huge amount of difference and just makes life so much easier. So in comparison to the standard Masuter, the Pro packs a lot of upgrades on the hardware and definitely designed to be a much more rigid machine. Now before I get stuck into any testing or any projects, there are three things that I needed to do: support the bed, install the Z probe, and then make a spoil board for it. It's only 12mm thick, and over that span obviously there's a bit of deflection going on in it. Now you could put some extrusion front to back connecting up the framework, but to be honest the easiest and cheapest solution is some offcuts of wood. These have been cut down to 28.8mm thick, and I'm going to put 3 in place to support the front, the middle and the back. So with all the work on the bed done, we'll now take the time to set the Z probe up. This is really simple. You connect the 2 connectors together, clip them in, make sure that is secure. You then take a reading of the actual block itself, and then we put that measurement into UGS, and that's all the work done for the Z probe. The next thing was to build a spoil board. This guarantees that the x-axis runs perfectly flat and parallel with the bed or the spoil board, and just improving the results we get from it. Now I deliberately did this with a 60-watt motor to give an indication of what it is capable of. It cut all these holes fine, didn't miss any steps. We even used the larger bit to do the surfacing in this little motor, and again it handled that fine as long as you take it at a sufficient speed and depth of cut. So obviously something like this you would need to go quite slow and shallow with. So with those 3 things out of the way, we can now get stuck in and start to do some stress testing, see how the machine copes. Even though you can see the Makita is installed here, I'm going to start off with the 60-watt spindle because that's what you get in the kit. So let's give you an idea of what that is capable of. The test I'm about to do is a bit of a speed and depth test. It'll cut a square out, a circle and an X, and each time it does one of the shapes it will lower it down 0.1mm. It will cut each one at the same speed though, and it's just an indication to give me whether the steppers go first or the spindle starts to get bogged down, and whether it will miss steps as it starts to go too deep. We set the 0 and run the Z probe in order to get the correct height. So this test went from 0.4 millimeters up to 1.5 millimeters deep at 500 millimeters per minute on every single pass. Now I'm not going to deceive you, these last couple of squares it was really struggling. I nearly hit the emergency stop. But the great thing about this test is all the squares are still in line, all the circles are perfectly round, there is no missing steps, so it's just a good indicator that even though this is a small spindle, it's still actually pretty powerful, and more importantly, so are the stepper motors to drive it. So with that out of the way, let's get the Makita into this and see what the machine can really do. So the first thing we need to do is remove the old setup. So we're going to take the wires off the spindle, push that to one side, and then take the clamp off. So we then bring in the 65mm holder, use the same bolts to put it in place but without the washers on them, and they should just fit in those holes, and position it in place and then start to put the bolts in. For the moment, I've not pinched these up too tight because once we put the new spindle in, we're going to need to retram it to the bed. So this is the Makita RT07 that we're going to be dropping in. It has a 65mm diameter shaft, which is perfect for this holder. Now, what I should say is this has different model numbers depending on which country you're in, but generally speaking, this is what it looks like, and as I say, it will fit this holder. You can also get same diameter in different brands such as Bowa or Katsu. They all make a very similar model. In fact, it's probably identical, but for now we are using the Makita one. The power switch and the speed control is here, so this will typically either be on the left or right hand side depending on how you sit it. So we should just be able to slide this in. In terms of how deep it goes, you want it somewhere roughly in the middle, so you've got a bit of travel up and down. So that is in place. One thing I should mention, if you like to try and cut deeper materials, you may want to raise the router up slightly in the holder, but ultimately it's about balance. You don't want too much weight sitting on top. Now at this stage, I also like to use a pencil and just put a reference mark on the router itself. Sometimes you may lose steps, but it can actually be the router slipping in the holder. So by putting a pencil mark on there, it just gives me an indication as to whether that's moved or it has actually lost steps. Now the next thing at this point is to tram the jig in, or tram the router into the spoil board that we've done. So we're going to put the jig back in to do the tramming. There'll be a link up in the corner showing you how to tram the machine in when you need to. Hopefully the camera can just pick this up. That's now touching all the way around, so it means it's trammed in correctly. Now you tram the holder in, not necessarily the spindle, so that means you can slacken the spindle off and lower it and higher it if needed, and it should stay trammed in. Now the next thing is to wire this up. I'm not going to show you during this video, but there is a link in the corner to how I've wired a previous machine up. You can either use an SSR relay or an IoT relay, and what this basically means is every time you start the machine up, it will start the spindle automatically, or sorry, every time you go to run a job, it will start the spindle automatically. So eagle-eyed viewers will notice the router has been switched around. I wanted the logo on the front, but actually also the cable fed better into the drag chain this way and allowed me to zip tie everything up and keep the cable management much neater. Now I did some basic jogging about and running with this, and what I started to notice with the extra weight of the router, the y-axis was skipping a little bit. The x-axis was fine, it was only on the y-axis. So what I've gone and done is installed a new set of wheels on both sides. These are anything between about $10 and $15. They take around 10 to 15 minutes to change all 8 out. It's really simple. There is a link in the top right hand corner at the moment, but it just meant that this moves around really smooth now. So what we're going to do is basically run a similar test that we did earlier with the smaller router, except we've upped the game a bit. We've taken the speed up by about 60% and we're doubling the depth of cut, so every time it moves on it's going to lower down about 0.2 millimeters, and we'll see how far through the grid it gets. If it gets more than halfway, great. If it completes the whole grid, then that's brilliant, because it means it's going to be cutting really deep at a decent speed. To give you an indication of the noise, it was averaging about 75 decibels during this test. So the purpose of this test was never about the capabilities of the router, it was about the capabilities of the NEMA 17 stepper motors. With them being small motors, this being a heavier weight router, I wanted to see how far we could drive it, and I said if we got more than halfway, I'd be really impressed. Well, we actually got 3/4 of the way through. So we got to 2 millimeters deep at 800 millimeters per second, and then when we get into 2.2, that's where it started to skip. Now bear in mind, this is hardwood ply, so it is pretty solid material. I also ran a similar test in MDF to see how it would cope. We got up to 3mm deep at 1000mm per minute. So again, very impressive for the strength of these stepper motors. And in terms of RPM, this was number 3 on the Makita, which I think is around 14,000 RPM. So now I've got an idea of what this machine can do in terms of its feeds and speeds. Let's progress and start to produce some projects with it. So I first started by doing a 3D relief carving of this ripple. I deliberately went aggressive with the step over to give these ridge marks, just to put some pressure on the bit. It handled it quite well, so I did the same job in plywood as well. Sometimes it could give some nice effects going through the different layers of the plywood, but ultimately it handled them no problem at all. Then took some softwood. I burned this several times to give it a very dark black coating, dropped it on the Masuter Pro, and as it is summer here in the UK, I carved myself a nice James barbecue shack sign, done as a 2-stage carving with a 1/8 upcut bit and then a V bit to finish and clean up the edges. Came out really nice. I then took this pattern and repeated it several times and cut them all out of oak faced MDF. What you start to do is then twist these slightly and stack them up on top of each other, applying a little bit of glue to the overlapping areas, and ultimately you end up creating some sort of bowl or feature or even a wall clock, and it can be mounted in different ways. With the wood projects out the way, I then started experimenting with aluminium. I did very shallow passes to begin with and it came out really nice. A very smooth finish, given this is my first time machining aluminium with this particular machine. And ultimately answering the question, can this machine metal? Well, obviously yes it can, and did a very nice job of it. This at shallow passes, 0.5mm at 500mm per minute. So I then started experimenting and doing some feed and speed tests, getting a bit deeper and a bit faster each time. I got this machine up to 1mm deep at 1000mm per minute. However, what we can start to see in this slow motion clip is that there is a considerable amount of wobble going on within the spindle, so this was clearly too aggressive for the machine. However, it was pretty comfortable in a range of around 0.7–0.8mm at about 800mm per minute. Curiosity got the better of me. I dropped a piece of stainless steel on the bed and started to play with that. I didn't do too much, but it just goes to show that it can actually machine dense metal like that. So taking what I'd learnt so far, we put it into practice and produced a YouTube plaque. I did this at 0.7mm per pass at a speed of 800mm per minute. It handled it really nice, gave a very smooth finish. I then buffed it out, did some work on the plate itself to give the finished piece. So it's time for the roundup, and if you've watched the whole video, you already know my verdict on this is going to be extremely positive, given the things we've been able to machine with it. The upgrades FoxAlien have made to this from the standard Masuter have brought it a long way and made it such a robust machine, given its mid-market price point below that $1,000 budget. Now, there was one small issue, which was the deflection in the bed. We covered that earlier in the episode. It easily overcome by putting some support underneath. I did think there was going to be an issue with the control box at the front. Obviously, where it's situated, it stops you putting longer pieces of material on the bed. However, by removing one small screw, you can pivot it out the way, and therefore you can put pieces of material on the bed as long as you can physically fit. So that issue has been moved out of the way and is no longer a problem. So as I say, the upgrades that have been made to this are really impressive, and it is definitely a great machine to begin. If you are around that budget of $600 to $700, this should definitely be at the top of your list. If you are thinking of buying one of these, please check out the links below. They are affiliate links. They do not cost you any more extra, but I may get a tiny bit back to help keep the channel going. Now, I have no doubt some of you are going to see the dust shoes. The files for these will be available soon. Keep an eye in the description area below. That is everything for today's episode. Thank you very much for watching. Final thanks as always goes to my patrons. If you want to get involved, early access to videos, giveaways, early access to files such as these dust shoes, then check it out and follow the links in the description area. I will see everyone on the next episode.